Hello audience, welcome to our YouTube channel. In the first part, we discussed the dev part of the DevOps life cycle. You can check this first part from the description box link. Now we would like to move on to the operation part, which is ops. As per our discussion earlier, we have progressed so far on the dev part cycle. Take a close look at the development cycle. Each developer's local source code is forked from the main GitLab branch source code and has its own Git branch. For example, the developer1 Git branch is dev1, the developer2 Git branch is dev2, and so on. When a developer1 completes the assigned task, then he will commit the source code from the dev1 branch and send a source code merge request to the main branch. In the same way, other developers doing the same things from their own Git branch. Every developer merge request is waiting to be approved. The team leader is checking each merge request and approved or reject the developer commit source code. If the approved source code is, then the source code is merged with the GitLab testing branch source code. When a changed source code comes to the testing branch, then CD automatically triggers for build on the source code and the entire source code is published on the test or staging server. According to the application deployment in the test, staging server, by Selenium, software quality testing, and by SonarQube, software security testing will be performing a test on the application. If a bug or vulnerability is found, then they will feed back to the concerned software developer to solve this problem. This is the way this application development will progress until the desired outcome is achieved. Now we would like to focus on the server machine. For example, we have a server machine that HDD 18 TB 7200 RPM SATA. CPU, Intel Xeon, Core, 32. Clock, 2.704.00 GHz. Cache, 48 MB. RAM, 64 GB DDR4. In this server machine, we have 4 virtual machines or VM. Now question is that what is the VM? A virtual machine, VM, is a computing resource that uses software instead of a physical computer to run programs and deploy apps. Each virtual machine runs its own CPU, memory, network interface, and storage, created on a physical hardware system, located off or on premises. Now that our application is running in a virtual machine and in this time interval we are introduced to containerization. 1. Containers create isolated environments in a physical server by virtualizing the host operating system and running packaged applications on top of it. 2. Instead of virtualizing the hardware like virtual machines, containers virtualize the OS. 2. It's built on top of a host OS kernel and usually shares its libraries and binaries. 3. Because it shares most of its necessities, containers only pack the application and its dependencies. They're much lighter than VMs and only megabytes in size. Here, we have seen some high-level design diagrams of containerization and virtualization. In containerization, each group of apps runs on binaries and libraries. All binaries and libraries running on the container engine. The host operating system is running on the container engine. On the other side, unlike containerization, each app is running different binaries and libraries. Each binary and libraries runs on a separate guest OS. A hypervisor is running between guest OS and host operating system. Here are some differences between virtualization and containerization. VM has multiple OS whereas containerization has single OS on a single server. VM replicates real hardware and containerization has OS-level virtualization. VM is heavyweight rather than containerization, and so on. A container is a piece of software that packages code and all of its dependencies. Containerization is the process of packaging software code along with all of its essential components. Some of the popular container providers are Docker, Oz ECS, Red Hat OpenShift, and Mesos. Docker is the most popular container among them. Docker is a containerization platform for packaging your application along with all of its dependencies. Docker is a free and open platform for developing, deploying, and running software. Advantages of Docker. Some of the benefits Docker delivers at various stages of the software development lifecycle, SDLC, are: build, test, deploy, maintain. As Docker has more advantages rather than VM, we would like to use Docker in the server machine to host our application, service, database, and so on. In a real project, a server machine contains a large number of Dockers. Sometimes it's required to create Docker dynamically or remove Docker as per demand. Manually, it is difficult to manage a large number of Dockers, so the question is how to manage a large number of Dockers. Here, container orchestration can manage the entire Docker system. So what is the container orchestration? Container orchestration automates the deployment, management, scaling, and networking of containers. It is useful for enterprises to deploy and manage multiple containers and hosts. Purposes of using container orchestration. A container orchestrator automatically deploys and manages containerized apps. It responds dynamically to changes in the environment. It ensures all deployed container instances get updated if a new version of a service is released. Dynamically respond to changes. Deploy the same application across different environments. Container orchestration tools provide a framework for managing containers and microservices architecture at scale. Some popular tools used for container lifecycle management are Kubernetes, Docker Swarm, Apache Mesos, OpenShift, and HashiCorp Nomad. Container orchestration and CI/CD pipeline cannot directly communicate with the Docker image. When a build is triggered through CI/CD pipeline, then it doesn't know in which Docker this source code will be deployed. Also, container orchestration has no idea of the network mapped to manage the Docker system. This network and configuration management system is required for container orchestration and CI/CD pipeline. Configuration management. It is a system engineering method that ensures a product's characteristics remain consistent during its life cycle. It provides a configuration model of the services, assets and infrastructure by recording the relationship between service assets, configuration items, controlled environments, operational use. Any change in configuration can dramatically impact performance, security, functionality. The advantages of configuration management are: 1. Increase efficiency with a well-defined configuration process that improves visibility. 2. Optimize cost by having detailed knowledge of all the IT elements. 3. Track requirements from specification to testing. Some configuration management system tools are SaltStack, Ansible, Chef, and Puppet. Now our application's entire management and configuration system has been done, but it is very important to monitor our application health checking. That is required continuous monitoring. Continuous monitoring is the ability to detect risk, compliance, and security issues in an operational environment. The roles of continuous monitoring are: assists in the design of a reliable system, displays application behavior during peak business hours, reduces cost by acquiring precise knowledge of software asset duplication, reduces the chance of an application going down, notifies you if there is a problem with your application service, retrieves and analyzes historical data. Types of continuous monitoring are: read-time monitoring, network monitoring, infrastructure monitoring, application monitoring. Continuous monitoring deals with: 1. Server CPU statistics. 2. Input-output count. 3. Disk usage. 4. API success or fail. 5. API HTTP error codes. 6. Performance matrices count. 7. API accessibility, and so on. Tools for continuous monitoring are Nagios, Elk, ZBBix, AWS CloudWatch, Grafana, and so on. So this is the final look at the entire DevOps cycle. Here, just developer work according to their assigned task. The team leader decided which feature needs to go on. Software security testing continuously checks the staging server, and the rest of the work will be run automatically. This is the same DevOps tools that can be used in different stages. Git and GitHub is used in the coding stage. Jenkins is used for the release. Docker and Kubernetes are used for deploy stage. Ansible is used to operate. Nagios is used to monitor. Selenium is used for software quality testing. SonarQube is used for software security testing. Maven Gradle is used to build. DevOps is a set of practices that aims to provide superior quality software quickly by integrating the processes between the development and the operation teams. DevSecOps, short for Development, Security, and Operations, is a development practice that integrates security initiatives at every stage of the software development lifecycle to deliver robust and secure applications. Here are more resources that you can explore from my personal blog website. Thanks for joining this entire DevSecOps journey. If you have any questions, then comment down below. Hope you enjoy this DevOps journey. Please like and subscribe to my YouTube channel. Have a nice day.